Today we'll be looking at our last section over radicals. Remember that we've been looking at simplifying radicals, operations with radicals, and then we looked at how to represent radicals as rational exponents. And our last section with radicals is going to be solving radical equations. So the first thing that we need to look at is what is a radical equation. A radical equation is going to be an equation with a variable under a radical. So it's not just that it includes a radical, because I could have an equation that has the square root of 2 in it, and that doesn't necessarily make it a radical equation. I would have to have something with the square root of x or the square root of a. That will make it a radical equation. So our first thing that we want to look at is our steps that are going to allow us to solve. So step 1 is to isolate the radical on one side of the equation. Our next step is to raise each side of the equation to a power equal to the index of the radical to eliminate the radical. And then lastly, solve the resulting polynomial equation. An extraneous solution is something that we might have seen before, but basically it is a solution that does not make the equation true. And we'll look at what I mean by that here in just a moment. So it says to solve each equation. So notice I have the square root of x plus 2 plus 4 equals 7. So notice that my x is underneath my radical. So this means that I have a radical equation. So our first step is to isolate the radical, or basically get our radical by itself. So in this case I have a square root of x plus 2. So I need to move anything that is next to or in front of that radical to the other side. In this case, we have a plus 4, so we would need to subtract 4 from both sides. So we end up with 3. Now, once we get our radical by itself, we need to raise both sides to whatever our index is. In this case, we don't have an index, but remember that if it's not a written index, that our index is understood to be 2. So I am going to square both sides. And the reason that we do that, remember, is because radicals and exponents are inverses of one another. So when I square a radical that has an index of 2, it undoes that radical. And so I'm just going to be left with whatever's on the inside. So we have x plus 2, and then 3 squared gives us 9. And then our last step is just to solve the resulting equation. So we would subtract 2 from both sides and get that x equals 7. So then we just kind of need to do a visual check for our equation. Notice if I plug in 7, I would have 7 plus 2, which is 9. The square root of 9 is 3. 3 plus 4 is 7. So this does make my equation true, and therefore x equals 7 is my answer. Alright, next up we have the square root of x minus 12 equals 2 minus the square root of x. Now this one is a little bit different because notice that we have a square root on both sides. So that's going to make our steps a little bit different. So notice that my square root of x minus 12, our first step is to isolate the radical. Well, my square root of x minus 12 is already by itself. So we're going to go ahead and work from there. So again, I don't have an index, so that means that our index is an understood 2. So we're going to go ahead and square both sides. But something to be careful about is that when we square both sides, I am indeed squaring the entire right side. So I'm not just squaring that square root of x there, I have to include the 2 as well. So again, my square root and my squared reduce with one another. So on the right hand side, we will have x minus 12. But on the right hand side, notice that we have 2 minus the square root of x squared. So we need to multiply out the right-hand side, but remember that whenever I square something, okay, that's like multiplying it by itself. So that would be 2 minus the square root of x times 2 minus the square root of x. So we need to FOIL this. So 2 times 2 gives me 4. 2 times a negative square root of x is negative 2 square root of x. Then we have a negative square root of x times 2, which is another negative 2 square root of x. And then we have a negative square root of x times a negative square root of x, which gives us a positive x. So simplifying, I get 4 minus 4 square roots of x plus x. And I did that off to the side just so that I could plug in a little bit easier and don't have to worry about trying to do all of that inside of my equation. Now, notice that we still have a square root in our equation. So basically, we're going to start the whole process over again. I need to isolate my square root. So I need to move everything away from my square root. So notice that my first step would be to subtract an x. And when we do that, I have x minus x is going to reduce to give me 0. And then we want to subtract that 4. So that's going to give me negative 16. And then we want to divide by negative 4, which is going to give us positive 4. Well, now that my square root of x is isolated, we can go ahead and raise both sides again to the second power, because when we do that, my squared and my radical are going to reduce. And we end up with 16 equals x. Now, the big thing here is we need to go back and check our answer again. So notice that if I plug 16 back into my equation, my original equation, 16 minus 12 gives us the square root of 4, which is 2. And then the square root of 16 is 4. But notice that 2 minus 4 gives us a negative 2. So because we had to square both sides, basically what happened is when I squared the 2, I got 4. And when I squared the negative 2, I also got 4. So when I squared both sides to solve, we basically made that negative go away. But when we look at our final solution, we know that that negative does matter. We know that 2 does not equal negative 2, which means that 16 is that extraneous solution, which means that this does not make it work. Well, if I only have one solution and that solution doesn't make my equation work, we're just going to say that we have no solution. Sometimes you might have more than one solution, and if that's the case, sometimes one solution will work and one solution won't, and you'll just have however many you have that work. In this case, since we only had one solution and it didn't work, then there is just no solution. And that's why it's going to be really important to always check your answers, because sometimes they're going to be an extra answer and not one that truly makes it work. So in our next equation, notice that it's technically still a radical equation. It just looks a little bit different. And that's because our radical is written as a rational exponent this time. However, our steps are still going to be the same. So my first step is to isolate my radical. Well, in this case, my 1/3 is acting in the place of my radical, so that's what we need to get by itself. So my first step is going to be to add 4 to both sides, then divide by 2 to both sides, and we get 2 on the right-hand side. So notice, though, that everything inside of my parentheses is being raised to that 1/3 power. So we can't add 3 or divide by 6 until we get rid of that 1/3. Now remember that 4 are rational exponents. Whatever's in the denominator is my index. So it's going to work the same way here. We want to raise both sides to whatever our index is. In this case, it would be 3. And the reason we want to do that is because notice 3 times 1/3 is just going to be 1. And so anything to the first power is just itself. So we end up with 6x minus 3 on the left-hand side, and then we have 8 on the right-hand side. A really important thing to remember is that you do have to raise both sides to that 3rd power. So don't forget to do it to the 2 as well. So then we're going to add 3 to both sides. We get 11, and then we divide by 6. Again, we can just kind of do a visual check in this case. So notice that if I were to plug it back into our x, 6 times 11 over 6 is going to be 11. 11 minus 3 is going to be 8. 8 to the 1/3 is going to be 2. 2 times 2 is 4, and then 4 minus 4 is 0. So this one does work. And so that would be my answer. Alright, let's look at one last example. This one is with a 1/3 this time. Again, like our last one. So remember that we treat our 1/3 just like we would if it was a radical. So we need to get that 1/3 by itself. So I'm going to add 1 to both sides, Then we need to raise both sides to the third power. But what's nice is that our 1 to the third is just still going to be 1. So we have 3n plus 2 equals 1. Then we subtract 2, which gives us -1. So we end up with -1/3. Again, doing a visual check, it does work. So that would be our answer. Alright, so that's our last example. Remember, the biggest thing is going to be how your radical equations can be written as either a radical, like we're used to seeing, or a rational exponent. But we can still solve them with the same steps, and we're just going to raise it to whatever our index is. And then the other big thing is to remember to check your solution for any extra solutions you might have.